All right, so our next subject area is logarithms. So logarithmic functions are the inverse of exponential functions. So they're actually the opposite. So for example, if you have 2 to the x power here, um, this is considered an exponential function. Its inverse would be log base 2 of x. Okay, so then we already have these tables set up for us. So for f of x, okay, this is our x values, this is our y values that we outputted. So my exponential function looks like this. This is my f of x. Now my g of x, my inverse function is my log function. Okay, these are the numbers when we plug in 2, 4, 6, 2, 4, 8, and 16. This is what my exponential function looks like. Now remember, if you can cut the two graphs into two equal parts or they're mirrored across the y equal to x line, that's considered what your inverses are. So to go more into logarithms, we have log base b of x equals y if and only if x equals b to the y power. So b stands for our base. Okay, so that's where our base would go. So I'm going to go ahead and write here, b stands for my base. Okay, and then y is our exponent. So here, when we write it in log form, that's where your exponent goes, or in this case, this is my y. And then last, so for example, if you do b to the y power, and it gives you x, okay, then you do, if you're looking for the exponent in reverse, you do log base b of whatever your answer was to the y power. So there's really no name for the x. I just like to call it the answer, okay? So for example, here it says write in exponential form, okay? So we're going from log form to exponential form. So this part right here is my answer. So my answer is 16 equals, and then we write our base. The base is 4, so I'm going to write 4. And then whatever it's equal to, that's considered my exponent. So it's going to be 4 squared, which we do know 4 to the second power does give us 16. But all we're doing is writing an exponential form. Okay, so let's go ahead and try this again. So the 32 this time is going to be our answer. Okay, so 32 equals, and then our base is a little number 2, so we do 2 to the power of 5, because this is equal to my exponent. All right, this next one, let's see, 1,000 is the answer, so I'm going to go ahead and write 1,000 equals. Now my log doesn't have a base, okay? So whenever your log doesn't have a base, it is automatically, I know everything else is automatically understood that it's an invisible 1, but that's not the way it works for logs. It is actually a 10, an invisible 10. All right, and then our exponent is this 3 right here. So my exponent is 3. And that's it. All right, so next we're going to go in the reverse order. So we're going to write it in log form. So let me make this a little bit smaller so you can be able to see or match up what we have to the top. Okay, so you always start with your log base. So I write my log. My base here is the 2. So it'll be log base 2, okay, the little 2. And then my answer here is 8. So it'll be log base 2 of 8 equal to my exponent. My exponent on this one is 3, so it equals 3. Okay, moving on to the next one. Here we have log. Okay, our base is 4. Okay, and then you write your answer. My answer here is 64, so I write log base 4 of 64 equals my exponent. So my exponent on this problem is 3. And then the last one, here we have 10 to the 0 power equals 1. So we start off by doing log base. And my base here is 10. So remember, you don't have to write the little 10, just like we don't have to write the x to the first power. You don't have to write the 10 on the log. It's understood. So log the 1 here. So we do log, my answer was 1, equals my exponent. My exponent here is 0. So it's equal to 0. All right, So here, the number e is an irrational number approximately 2.71828. The natural logarithm function f of x equals ln of x is the inverse of your exponential function with the natural base e. So f of x is equal to e to the x. So pretty much whenever you see ln, it's called the natural log. So for example, if you had log with the little base e of whatever number here, I'll just put, what do they have it as? X equals y. Instead of writing log base e, we rewrite it as ln, the natural log. Ln of x equals y, so that you're understood that that little number here is supposed to be an e. Okay, and the e is an actual number, even though it's a letter, it represents a number, and that's a number that it represents. Okay. So here they show us how to go back and forth. Now this is your answer. This is still your exponent. Okay, this is my exponent, and this is still my answer. So let's go ahead and try some problems here. It says ln of c equals 3. We write it in exponential form. So because I do see the natural log, that means my little base here is e. So it'll be e. This is my exponent, so e to the third power equals my answer, which is c. Okay, we're going to try this again. Remember, this is the natural log, so the little number here that's supposed to be there, but it's understood is e, equal, let's see, e to the 6th power equals my answer. My answer here is b. Okay, the next one, we have the natural log again. That means my base is e. My exponent here this time is x. So to the x power equals this number here that's with the natural log for. Okay, now we're going backwards. So now we have e. So then when we write it down, we're going to write it as ln. Okay, my answer here is 7.389. 9 equals my exponent. So my exponent here is a 2. Okay, so here I see e to the 4th power. So that tells me automatically when I'm rewriting, I write it as a natural log. So ln of, our answer is b. So ln of b equals my exponent. My exponent here is 4. Okay. The next one, again, I see e, so I'm going to write the natural log. So ln, my answer here is 12. So ln times 12, or ln of 12, not times 12. Ln of 12 equals my exponent here is 8. All right, so it says evaluate the following logarithms, show your work. Okay, so here we have log base 4 of 64 equals blank. Okay, so since they do want us to show work, this is pretty much asking, I'm going to rewrite in exponential form. It is asking 4 to what power, we don't know what that power is equal to 64. Okay, so you got to figure out what power it is. So 4 to the first power is 4. 4 to the second power is 16. So 4 to the third power is not 16, 32. Let me see. 4 to the third is, oh no, 4 to the third is 64. So that means that that number in here should be 3. Okay, so then let's go ahead and try the next one. This is saying 5 to what power? We don't know what this is. That's what we're looking for. Is equal to what? Well, in order for 5 to be to a power and it gives you 1, the only number possible, remember, anything to the 0 power is going to give you 1. All right, the next one, this is 2 to what power is going to give me 1 over 8. Okay, so obviously I can see since it's 1 over 8, it ends up giving me a fraction that this number in here is going to be a negative. Okay. And then let's see, 2 to what power gives me 8? So 2 to the second power gives me 4. So that means 2 to the third power, 4 times 2 gives me 8. So it'll be negative 3. Okay, negative 3. All right, this next one we have 0.0001. Okay, and then we don't have a base here, but it is 10. So we're looking 10 to what power is going to give me 0.0001. So I don't know if you guys remember scientific notation, right? So for scientific notation, since the decimal is here, we move it over 1, 2, 3, 4 times. So because we would move the decimal over 4 spaces, this would be to the power of negative 4. 1, 2, 3, 4. Yeah. Let me just double check in my calculator because sometimes I do not trust my math. Let's see. What the heck? Okay, we should be good. All right, next, we have log base 1 over 16. And then 2 of 4 equals. So that means our base, remember our base is this little number here. So it's 1 over 16 to what power is going to give me 4. Okay, so we're looking for what exponent. Now, it's 1 over 16, so that's going to tell me right away that it is going to be a negative number. Okay, so let me see. We know 4 squared gives me 16, right? So then I believe, let me see. It might be a fraction because if we take the square root of 16, that would give us that would give us 4 when we take the square root of 16. So let me just double check. Yeah. So it's going to be negative because the 16 is on the bottom. It's in the denominator. And then if we take the square root of 16, that would give me 4. So it'll be negative 1/2. Okay. And then this last one, so I'm going to rewrite this in exponential form. So it'll be 10 to what power? Because remember the base here is 10 equals the square root of 10. Well, remember the square root of 10, whenever you take a square root, to write it as an exponent, the square root, it will be 1/2. That's it. Is there another one? No. Okay. Now they want us to solve the following equation. So we're solving for x this time. So if it's in log form, we need to change it into exponential form and vice versa. So I'm going to go ahead and change it into exponential form. It'll be 6 squared equals x. Well, we know that 6 squared gives us 36, so that means 36 equals x. Okay, ln of x equals 2. So this is going to be e to the second power equals x. Okay, since it's a natural log. Now, e is an actual number, so it's going to be e squared. So that'll give us 7 point. It doesn't tell us what to round to, so I'm going to round 2 decimal places. 0.39 equals x. Okay, the next one. This one tells you log of x squared plus 19 equals 2. So I'm going to go ahead and write it in exponential form. Okay, the base here is going to be 10. Remember, if there's no base, we automatically know it is 10. So it's 10 to the second power. 10 to the second power equals x squared plus 19. That helps me rewrite it into exponential form when I forget or if I need extra help. So 10 squared gives us 100 equals x squared plus 19. We subtract the 19. 100 minus 19 gives me 81. Then x squared, we go ahead and take the square root. And that ends up giving us, remember if we take the square root of 81, that's going to give me plus or minus 9. Okay, because 9 times 9 gives me 81 and negative 9 times negative 9 gives me 81. All right, this next one, so we're going to do 6 to the first power is equal to this. So it'll be 6 to the first power equals log base 2 of x. Okay, and then we have to rewrite it again. So we have our base here, so it'll be 2 to the 6th power equals x. So 2 to the 6th power is equal to x. So I'm going to go ahead and do 2 to the 6th power. That gives me 64, so that means 64 equals x. Is that it? Yeah, that's it. So thank you guys. We'll see you next time. Bye.